Hello, everyone. This is Miss Espinosa. I wanted to take a moment to look over some of the math skills that you guys are going to need for success in this class. Ideally, these are all skills that you have already before you come into my classroom. But I wanted to make sure that I didn't assume that everybody remembers. It's been such a long break. Every summer is always a long break, so we want to make sure that you have remembered these skills. Maybe some of you just need a quick little refresher. I also want to give you a heads up that everything that you are going to be asked to do in this math review assignment is going to be super important in everything that you turn in to be graded. I know that sometimes some students feel really confident that they understand how to find the final answer, but maybe leave out some details along the way, or they're a little careless with some of those details in interpreting or showing their work. But in this class, you will be graded not only in your ability to give me the correct final answer, but also in your ability to recognize when values are expressed correctly or incorrectly, recognize when units need to be changed or measurements need to be converted, and your ability to completely correctly express your final answer and the steps that you took along the way to acquire that answer. So please make sure that you are taking time and looking closely at the details of the work that you are turning in throughout the class period, because it will add up, okay? So this very first section that we have here on this paper is just a chart where we have some various types of measurements, and then we have a place for you to indicate what the desired unit should be for that measurement, and then the symbol or the abbreviation that we're going to use whenever we are expressing that measured value with the unit. So you can see that our first example here is length in meters, and that's going to be written as an M. So throughout the year, if you are either reading a word problem or maybe you are simply interpreting data that is provided on an illustration, if it says 1.5 M, that stands for meters, not miles. And yes, it makes a difference in our class whether it's meters or miles, okay? Sometimes students struggle a little bit with understanding the difference between M for meters or MM, which stands for millimeters, right? And then we're going to use km quite a bit in this class, which stands for kilometers. So recognizing that all of these have a root or a base unit of meters means that it's automatically going to be some sort of length. So distance, height, displacement, things like that. Knowing the difference between a meter, a millimeter, or a kilometer is going to be very important, because in our class, the equations that we're using are written so that we have a specific unit that goes into the calculation. So if the formula is written for your displacement to be in kilometers, but you plug in a value that is actually expressed in meters, then you're ultimately going to calculate an incorrect answer because your units are not correct. So you need to recognize the difference, and you need to know how to perform that conversion. So in our class, you will be expected to know by heart the prefixes from tera to nano. So if you do not currently know the metric prefixes from tera to nano, then you need to work on that, okay? You will not be provided a chart. You will just have to know what the symbol represents, what prefix that is, and how you need to go about completing that conversion. So on this handout, you see that we have a couple of examples here. This process is called dimensional analysis. I think that I've heard some students say that it's the fraction method. Perhaps you heard that somewhere from one of your teachers along the way, but the correct word for it is dimensional analysis. You will be expected to perform your conversions using dimensional analysis in my class. So if that is not something that you currently know how to do, or maybe you've kind of forgotten, then we need to make sure that we get that cleared up pretty quickly, okay? Because this is something you will have to do on a regular basis. In this class, you will be given values, and some of them will be in the correct unit and some of them will not. So you will need to recognize whether the formula needs that value to be in kilometers or meters, and then you will be expected to perform the conversion before you plug it into your equation and then complete the process. Rounding and expressing your final answer in the appropriate number of significant figures is a very detailed part of the work, but it is going to count. You will be graded that you did or did not round correctly, express the correct number of significant figures, express it in the correct metric unit. Okay, so please, 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 as you work through your practice problems and as you complete your quizzes and your tests and things like that, you must make sure that all of those little things are going to be graded. Your written work will be analyzed, and all of the steps along the way are also going to be graded and count towards points. So be careful that you are not just expressing the final answer. You need to show me the steps that you took along the way, and we'll talk about what that should look like and where those points are coming from in more detail as we progress. But you need to make sure that all of those little details about your final answer as well are very clear and that they are correct. Okay, so rounding 5 or greater, it's going to round up. 4 or less, it's going to stay the same. How many significant figures should you use in that rounded answer? In other words, should you tell me that the final answer is 1.275, or should it only have 2 significant figures? So it would be 1.3. So things like that are going to count for points, okay? So right here we have some basic rules for sig figs, and I just want to briefly go over these. Some of them are very easy to remember. Some of them students get confused on. So I want to make sure that I try to review and hopefully clarify for some of you. All non-zeros are basically numbers 1 through 9. Those are the easy ones. Zeros to the left never count. So we go from left to right. If we're reading a book, right, we're going from left to right across the page as we read. So whenever we say that zeros to the left, I like to say leading zeros, because if we think about it, if we're reading a number, this first digit is going to be the left number. So I like to call them leading because it's the first number, right, in our written number. So leading zeros are never significant. Now let me ask you a question. Do we ever express whole numbers starting with a 0? No. So pretty much all whole numbers are not going to have zeros at the front. When might we have zeros at the front, or leading zeros or zeros to the left? Usually we are looking at a decimal situation, okay? Now honestly, it does not matter where my decimal is located. In both of these cases, that's a leading zero, and they are not going to count ever, okay? The next rule here says that we have zeros in the middle that always count, so sandwich zeros. So if you think about it, if the number in front of it and the number behind it, numbers 1 through 9, are there and there's a 0 in the middle, well, yes, by default it has to be there, because 101, 101, if you take out the 0, then it's a 1, 1, that's an 11. They're two different values, right? So that 0 is significant. So zeros in the middle, as they say it, or I like to say sandwich zeros, are always going to count. Zeros to the right only count if there's a decimal. So if you are going to struggle, this is probably the rule that is going to get you. Zeros at the end only count if there is a decimal present, okay? So whole numbers most definitely can end in a 0. But does that ending 0 matter? Well, if it's a whole number and that's it, those ending zeros are not going to count because there is no decimal present. If we have the number 250 and it's written just like this, this is going to have 2 sig figs because ending zeros don't count. If we have the number 250 point, that is going to be considered 3 sig figs. Well, what's the difference? The decimal point. And the rule says zeros to the right count if there is a decimal in the number, okay? So what if it's a 0.250? That's also going to be 3 significant figures because we have a 0 at the end and there's a decimal present, all right? So If students struggle, this is most often the rule that gets them. So make sure that you take time to learn what the rules are for sig figs. When you go to express that final answer, make sure that your final answer is representing the correct number of sig figs, which most of the problems that we're going to work in here are going to be multiplication and division. So it's going to be whatever the least number of sig figs that you were given in the problem. So let's say that you perform a math calculations and there's 5 numbers that you threw into your formula. Of those 5 numbers, what was the least number of significant figures that you were given? If all of them had 5 sig figs, but you have one number that only had 3 sig figs, then your final answer is going to be expressed in 3 sig figs, okay? The addition and subtraction is going to be to the decimal place. In other words, was it to the tenths, the hundredths, or the thousandths that the values were given to you of the numbers that you used in your math calculation? If the least that you were given was to the hundredths place, then your final answer is going to be around to the hundredths place, okay? So make sure that you review those rules and learn them if it's not something that you already know, okay? Percent uncertainty, we're going to talk about that more as we do some of our labs and answer some of those pre-lab questions, but basically it's taking the percentage difference between what you actually calculated and what you were expected to calculate, okay? Trig, guys, you have to know your trig, all right? So in geometry, you should have learned about some basic rules of, what should add up to 90 degrees, what is a right angle, what is a value of 90 degrees, what is a 180. And so you were also taught with that how angles can pair up, how they can be comparable angles, or how they are similar or the same angle, how they are going to combine to add up to a 90 or 180. Those rules are going to be applied when interpreting some of our scenarios that we're going to be using to pull our values so that we can perform our math calculations. So make sure that you understand right triangles for sure, because we are going to utilize a lot of right triangle math in our physics. But just kind of in general, you should remember some of those basics about what should add up to 90 and what should add up to 180, okay? Without doing a full lesson here, I just want to briefly review for right triangles. Pythagorean theorem is going to be a squared plus b squared equals c squared. Make sure that you understand that you are squaring the values of those sides. And then SOHCAHTOA. Do you know what the acronym SOHCAHTOA stands for? And do you know how that's going to help you write out your formula? So the SO in SOHCAHTOA is going to be the sine of theta is equal to the opposite side of your triangle over the hypotenuse. The cosine or CA is going to be the cosine theta is the adjacent side of your triangle over the hypotenuse. And then TOA stands for tangent. So your tangent angle is going to be your opposite side over your adjacent side. So if you are not already comfortable with this right triangle math, please make sure that you take some time and freshen up on that, because we will absolutely be using that quite a bit as we work through some of our chapters here within the first 9 weeks of class. So that was it. Just wanted to give you an idea of what to expect as far as some math basics goes. When you are given the opportunity to do your practice work, please make sure that you make time to perform the math practice so that when you get the opportunity to ask me questions, you know what you do or do not need help on. If you don't have the time to get all of the assignment done before the Q&A session comes, can you at least take 5 minutes to look over the assignment and just kind of skim through them and eyeball them and say, I think I know how to do this. Oh, I absolutely know how to do that. I have no idea what I'm supposed to do here. So that when we get to the Q&A, you have some idea as to what types of problems or what sections of the assignment you need to ask questions about or you need clarification on, okay? All right, I hope that was helpful. Please reach out to me if you have any questions at any point in time. I am more than happy to take time out with you individually as needed, or if I have a lot of students that are asking the same types of questions, then I'll just address it as a whole class kind of activity so that we can all get on the same page so you guys are ready to go when it comes quiz and test time for these math questions. Have a great day.